So in the first part of our review, we're going to take a look back at how we count atoms and break down chemical formulas, how we can identify the different parts of a formula, the different elements, and how many atoms of each element there are in a particular compound. So the first thing we're going to go back and look at is elements on the periodic table. Each box on the periodic table is a different element. And in those boxes, there are the chemical symbols or abbreviations for the element names. Every single element on the periodic table has an abbreviation that's made of either one or two letters. In very rare cases, there are elements with three-letter symbols, but those are newer elements that don't have their official name yet. The ones that we're going to be dealing with will all have either one or two letters. But if you look at each box, there's never more than one capital letter in each element's box. Some elements only have one letter, like hydrogen, oxygen, carbon, and those elements, that's their symbol, just the one capital letter that identifies that element. And then there are other elements that have two-letter symbols, like helium, chlorine, sodium, and the list goes on. But there are never, ever any element symbols that have two capital letters. It's either one capital letter by itself or a capital letter with a lowercase letter. Never two capital letters. So that means that when we're looking at a formula or any element symbol, even if it's not a compound, we know that every time you see a capital letter, that's a different element. There's never ever a symbol with two capital letters. So every capital letter in a formula represents a different element. So let's take a look at a few formulas and identify the elements and how many elements there are in each formula. So it might help when if you're doing this on your own, or when you're looking at these on a worksheet or something like that. It might help to draw lines next to each capital letter. So for example, if we have this symbol or this formula, NaCl. This is a pretty familiar one. It's for chlorine. There's a capital letter here and a capital letter here. So I'm going to draw a line in between the lowercase letter and the next capital letter. That tells me that there are two elements. Right? The Na is one abbreviation, the Cl is another. Sometimes this one can get tricky because the lowercase l and the uppercase I and some fonts and things like that look the same. But you just have to keep an eye out for that one in particular. Okay, so that's one example. Here's another one. NaOH. So again, if you want to break this down, anytime you see a new capital letter, you draw a line, that tells you that those are separate elements. Right? So we still have Na, which we had in the last formula, that's sodium, and then we have a capital O and a capital H. The fact that there's a capital letter, two capital letters next to each other, still means they're two different elements. There's no element OH with a capital O and a capital H. So there's actually three elements in this compound: sodium, oxygen, and hydrogen. KCl. Okay, again, you have to be careful with the lowercase l. Sometimes looks like an I. But if I draw this line between the capital letters, that helps me separate. Well, that's K, potassium, capital, and then capital C means this is a new element, and it's Cl with a lowercase l. So that's chlorine. So this has two elements in that compound. Okay, here we have K, capital, I, capital, no lowercase letters, and that'll happen sometimes if you have two elements in the same compound that both have one letter abbreviations. So potassium is an element. This is I for iodine, which is its own element, and we know they're two different elements because they're both capital letters, two elements in that compound. Okay, here's another compound. Now this one happens to have all capital letters. 4 capital letters, no lowercase letters. It has this little number down here, which we're going to talk more about in a minute. But the fact that there's a capital letter, capital letter, capital letter, break that down. There's N, that's nitrogen, H is hydrogen, O is oxygen, H again, right? There's two H's in different places, but they're both capital H's, which means they're both hydrogen. So that's 1, 2, 3, 4 elements in that compound. All capital letters. So don't be fooled by the fact that there's a bunch of capital letters all strung together. Every single capital letter is a different element. Here's another one that again is all capital letters. And yeah, we have hydrogen here, and then we have two oxygens next to each other. And that might seem a little weird. Why wouldn't you just put them together and put the little 2, which we're going to talk about the subscripts in a minute. It's something called a structural formula, and it just has to do with more the way that the molecule itself is put together. But for our purposes, it doesn't matter. Capital letter, capital letter, capital letter, capital letter, capital letter. Now, there's 5 different capital letters, but since the hydrogen and the oxygen are doubled up, if you're looking at the number of elements, there's really 3 elements. There's carbon, hydrogen, and oxygen. There's 5 atoms, right? There's a carbon, a hydrogen, an oxygen, and hydrogen. Those are 5 separate atoms, but there's only 3 different elements. So we've already seen an example of this as something called a subscript, okay, which is a number that we see in formulas as a little number kind of set down below. So it would be the opposite of an exponent. It would look like a footnote is another notation that uses something like this. So what that means is the subscript tells you that whatever element came before it, whatever capital letter came before it, there's more than one. Okay, when there's no number, right, there's nothing there, that just means that there's one oxygen, for example. But when there's a number, it tells you that there's more than one, and it tells you how many there are. H2 means that there are 2 hydrogens and 1 oxygen. So there's a total of 3 atoms. Okay, so that's what that subscript means. If we look at another one, for example, CO2, well, how many, there's 2 capital letters, there's this one subscript next to the O. Now it only affects the number or the capital letter that's just before it. It doesn't go to all the letters in the formula, it only affects the one that it's next to. So in this case there's 2 oxygen, that's oxygen, and 1 carbon. So it's a total of 3 atoms, 1 carbon, 2 oxygens. And sometimes you can have, other numbers besides 2. Right? Here's PCl3. Again, the 3, and this is one of the with chlorine. Keep in mind that the 3 applies to the chlorine, which has a capital letter C. Right? So this is phosphorus, which is a different element. This is chlorine, and it says Cl3. So that means there's 3 chlorines, 1 phosphorus, total of 4 atoms, but 3 chlorines and 1 phosphorus. Another thing that we might see in a formula is parentheses, okay? And when it comes to the parentheses in a chemical formula, it works a lot like the parentheses do sometimes in math, right? Where we have, in this case, CaNO3 in parentheses with a little 2 next to it. So this subscript, which is outside the parentheses, applies or multiplies everything that's inside the parentheses and nothing else. Okay, so it doesn't go all the way back and affect the Ca, the calcium, right? That's one element. There's another element, and the oxygen is another element. Okay, so if you're looking at elements, there's 3. 3 capital letters means 3 elements. But if you want to start counting the atoms, which is going to be important for the next thing we're going to do, you need to look at the subscripts, and when there's parentheses, the number outside the parentheses, in math you'd call it distribution, right? It applies to everything inside the parentheses. This group in the parentheses gets doubled. So this is 1 calcium. Nitrogen has no number next to it, so that means it's a 1, but because it's in parentheses with this 2 outside, there's 2 nitrogens. The number outside gets multiplied times any number that's inside the parentheses. So this is O3, There's 3 oxygens in the parentheses, but the parentheses gets doubled. So there's actually 6 oxygens. Okay, so 1 calcium, 2 nitrogen, 6 oxygen in that formula. Here's another one. Al2 parentheses SO3 parentheses 3. So we got a bunch of numbers here. We got Al, so that's one element. We've got S is another element, O3. So the 2 with the Al tells you that there's 2 Al. The S is in the parentheses with the 3 on the outside, so that means that there's 3 sulfur. And then the 3 on the outside gets multiplied times the 3 on the inside, which makes 9 oxygen. Okay, so again, the number outside the parentheses over here with the aluminum only applies to the aluminum. The number next to the parentheses here multiplies everything in the parentheses, but doesn't go back and multiply the aluminum. It only affects the stuff in the parentheses. And just to look at one more example, Mg3 PO4 2. So here we go again. We've got subscripts all over the place. We've got magnesium with a 3, so that means there's 3 magnesium. That's pretty straightforward. The little number next to the magnesium, capital letter M, little g, that's one element. With the 3 means there's 3 of those. Then we go into the parentheses. There's 2 different elements. There's the phosphorus and the oxygen. The phosphorus has no number next to it, but there's the number outside the parentheses, so that gets multiplied times the phosphorus, so there's 2 of those. The O, this time has a 4 next to it, times the 2 on the outside, 2 times 4 is 8. So there's 8 oxygens. 3 magnesiums, 2 phosphorus, 8 oxygen because of the parentheses and all the subscripts involved. Okay. So I'm going to take a look at some formulas and counting up the atoms. I'm going to bring in a little bit of a visual aid here. So you could do this yourself. It might help to have the visual with it. I'm going to use some Legos because I got a bunch around. But you can use anything where you have a handful of different types of things, like you could use different coins for this, or paper clips if you have different color or different size paper clips maybe. Or different color sticky notes, something like that. It works. Or you could even draw different color circles. But I like having the things that you can move around in case you make a mistake. You can undo things. So here's some simple formulas. Here's KOH. Right? So 3 capital letters. Don't forget you can draw the lines to help. So we have 3 different elements, and let's call K is light blue, oxygen is going to be white, and hydrogen will be dark blue. Well, there's no numbers in here. There's no subscripts. So that means that each one of these elements only has one of the atoms. So there you go. There's your compound, KOH. 1, 2, 3 atoms. One potassium, 1 oxygen, 1 hydrogen. And then if we take a look at something like NaF. Okay, where's the line? Well, there's a capital and a lowercase, and then another capital. So there's the separation between them. It's sodium, it's fluorine. I'm going to repeat my colors here. 2 different colors, 2 different elements, no subscripts, so that means there's just one of each. And that one's done. If we have CaCl2, okay, let's take a look at this. Here's capital, lowercase, capital, lowercase. So I put a line between the first and the second element. Let's make this calcium and this chlorine. Since there's a 2 next to the chlorine, that means there's 2 chlorine atoms. Right? So just counting them up. So 1 calcium, 2 chlorine, and then, if you want to make the compound, you could certainly put those together. There's your compound. Calcium, 2 chlorines. Calcium chloride. Let's look at a couple that have parentheses just to, again, reinforce how that works. Here's calcium. That's an element. no subscript there. So let's make the light blue calcium. Then in the parentheses we have oxygen, hydrogen, 2 capital letters. Okay, neither one of them by itself has a subscript. Okay, so in the parentheses there's only one of each, but outside the parentheses there's this 2, which means it doubles everything inside the parentheses, so that we have 2 oxygens and 2 hydrogens. Okay, we still only have the 1 calcium, but what it really is there's these groups. Okay, there's a group of OH and there's another group of OH. So there's 2 groups of OH, which when you're counting the atoms is 2 oxygens and 2 hydrogens. Okay, and then if we have something like NH4 2S. Okay, so let's see. There's NH. Okay, there's these two elements here. Then there's the sulfur out here. So here's nitrogen. We'll make that hydrogen. Here's sulfur. Oh, sorry, I need a different color. Sulfur. The sulfur is by itself over here and it has no subscript, so there's only 1 sulfur. The parentheses, you've got N with no subscript, so there's 1. The hydrogen in the parentheses has a subscript of 4. Okay, so there's 4 hydrogens. But then you've got the 2 outside the parentheses, which means everything in the parentheses gets doubled. So that means there's really 2 nitrogens and 4 more hydrogens. So you double everything in the parentheses. Okay, so total is 2 nitrogens, 8 hydrogens, and 1 sulfur out here again, because it's an element by itself, no subscript, no parentheses, you're done with the sulfur. Just to do one more, we've got aluminum, NO3, 3. Okay, so here's again a bunch of subscripts, we've got parentheses. Let's find our elements. Okay, there's aluminum, nitrogen, oxygen. Okay, so the aluminum has a 2 next to it, so there you go, 2 aluminums. The nitrogen has no subscript in the parentheses, so that's a 3. And then the oxygen, so that's a 1. The oxygen has the 3, so there's 3 oxygens in the parentheses. Outside the parentheses, there's the 3, which means everything in the parentheses gets multiplied by 3. So now there's 1, 2, 3 nitrogens, and another group, 2 more groups of 3 oxygens, for a total of 9. Okay, there's 9 oxygens, 3 nitrogens, and 2 aluminums again, because the aluminum's by itself with its little 2 out here, so there are 2 of them, but the 3 over here doesn't affect the aluminum because that parentheses closes off the effect of the 3. Just to show you one that has, again, sometimes if you look, every capital letter is a different element. Sometimes they appear more than once. Okay, so here's nitrogen. None of these have subscripts. Nitrogen, hydrogen, oxygen, hydrogen again. So when you're looking at the elements, right, there's 1 nitrogen, there's actually 2 hydrogens, which will be important later when we're doing the mass. And there's 1 oxygen. So even though there's no subscripts, there's still 2 hydrogens because it appears twice, 2 capital letters. Don't get confused again, thinking that, well, there's an H over here, so this must be NH, and maybe that was supposed to be a little h. No, capital letters are their own elements, even if they appear more than once in a formula, which does happen. Doesn't happen all the time, but it can happen. Don't get fooled by those. Capital letters are their own elements. Okay, so the last thing that I wanted to look at here, which is really introducing something that we're going to use, and we've seen it before, but we're going to use it more in the next topics that we're going to cover, which are balancing chemical equations and then something called stoichiometry. So a coefficient is a number that appears in front of a formula. Okay, so for example, if we have something like 2NaCl, okay, so this big number here is called a coefficient. Okay, that's a number, or that's a term that comes up sometimes in math, but in terms of science and chemistry, it'll come up in physics too. There's different things called coefficients of drag and things like that, coefficients of friction. But for our purposes, coefficient is a number that appears in front of a chemical formula. Okay, we're going to use this much more when we start talking about reactions and equations and things like that. It affects everything in that formula that appears after it. Okay, so this is different from the subscripts or the subscripts with parentheses, which kind of get cut off at different points. A coefficient in front of a formula means that there's double or triple or quadruple or whatever the number is of everything in that formula. Okay, so let's take a look. So 2NaCl. Well, there's no subscripts here. Here's your breakdown of where the elements are. There's a sodium and a chlorine, if we want to throw the Legos on here, just to show you. Well, the formula has a sodium and a chlorine, one of each. The coefficient means that there's 2 NaCls, and since each NaCl has one chlorine and one sodium, that means 2 sodium chlorides has 2 sodiums and 2 chlorines. So again, when we're talking about balancing and mass and things like that, understanding the difference between the coefficient and then a subscript which might appear inside the formula is very important, because they affect the numbers and the amounts differently. So let's take a look at a formula with a subscript. Okay, so H2O, it's one we're all familiar with. If I put a coefficient here, if I break up the elements, it's H2O. So by itself, that means 2 hydrogens and an oxygen. The coefficient affects the entire amount of the entire formula. What we're really saying when we use a coefficient is that we have 2 units of water, and 1 unit of water is H2O. So 2 units of water has 2 hydrogens, well, a total of 4 hydrogens and a total of 2 oxygens, right? Because it's H2O twice. Okay, that's what that means. It's H2O twice. Sometimes a molecule only has one element. Right? There's only one capital letter. This is kind of might be a little confusing. This is 3O2. It's not 32. It's 3, and this is oxygen. I'll color code it a little bit to make it maybe a little easier. Right? So the blue is just the numbers, and the black ink is the symbol. So 3 O2s, well, O2 is 2 oxygens. That's what the subscript means. 3 O2s means 3 units of 2 oxygens each, or a total of 6 oxygens. Okay, so it's O2 3 times. That's what the coefficient means. And then if we have something like 2CaSO4, okay, here are the elements: calcium, sulfur, oxygen. 3 different elements, 3 capital letters. There's a subscript on the oxygen. So the 4 here only affects the oxygen because that's the element right in front of it. So if we take a look, there's calcium, there's a sulfur, and there are 4 oxygens in this molecule, or in this compound. But the coefficient means there's everything in here twice. There's 2 units. So there's another calcium, there's another sulfur, and then there's 4 more oxygens. So it's CaSO4 twice. That's what the coefficient here tells us. Now, when there's a formula with parentheses, we've seen how the parentheses and the subscripts can be affected, right? So if we have CaOH2, and we have a 3, there's your coefficient here. So there's Ca, capital O, capital H, that's oxygen and hydrogen. For the Ca, there's 1, because there's no subscript with it. For the O, there's 1, no subscript in the parentheses. And the hydrogen, there's 1 in the parentheses. The parentheses and the subscript tell us that there's actually 2 units of OH in the molecule, right? So just by itself, there's 1 calcium, 2 hydrogens, 2 oxygen. Because of that little 2, the parentheses means everything in there gets doubled. Then when I add the coefficient, everything in this whole thing gets multiplied by 3, or there's 3 of them. Or there's 3 units, right? So there's 3 units of calcium, 2 oxygens, 2 hydrogens. So that's 2, and then I got to do it again because it says it's 3 times. Okay, so there's total of 3 calciums, 6 oxygens, and 6 hydrogens, because the 3 now affects everything in here. It affects the 1 that's down here where we don't really put it, but for the calcium, so there's 3 calcium. And it multiplies times the number outside the parentheses, which then multiplies times everything in the parentheses. So 3 times 2 means 6. So 6 oxygen. There was originally 1, or originally 2. So 3 pairs here, 3 pairs here, so it's a total of 6 of each. And then just to show you one that's got a little bit of everything, let's take a look at 2Al2SO3 3. All right, so we've got aluminum with a 2 next to it. We've got sulfur in the parentheses, no subscript. Oxygen, 3 in the parentheses. And then there's a 3 outside the parentheses, and then there's a coefficient of 2. So we got all sorts of stuff going on here. So let's just break this down. 2 aluminum, that's one group there. 1 sulfur, 3 oxygen, okay, that's in the parentheses, and then everything in the parentheses gets multiplied by 3. So 3 sulfur, and then 3 more oxygen, and then again 3 more oxygen. Okay, so the total, 3 sulfur, 9 oxygen in this formula. 2 aluminum, 3 sulfurs because of the 3 outside the parentheses, and 9 oxygens. Oxygen 3 times 3. Well, then we put the coefficient here, which means everything in here there's 2 of, or twice as many of. So it means there's 2 aluminums twice. It means there's 3 sulfurs twice. And, I'm going to run out. But there's 9 oxygens twice. And I didn't have enough bricks. I should have counted before I started, but there should be a total of 9 white squares here. Okay, so in the next section, the next assignment, the next video, the next lesson, we're going to take all this information about formulas and subscripts and parentheses and the periodic table, and we're going to revisit the concept of molar mass, of elements and compounds. So there you go. We'll see you next time.